the slides?
I'm trying to figure out how to display my screen, but still get access to the tool. I guess I could just share my screen and then go from there.
You should be able to pre-upload the PDFs for the slides and then share them.
I think we went through this last time. They are preloaded, and then will it?
You have to load them into Meet Echo separately to have them on the data tracker, but then you should be able to share them.
Will it just share from within the tool and not a separate window?
Yep.
Can you walk me through it?
Not easily, because I don't have the chair view, because I'm not chair of this.
Okay,
group.
I've got the slides up.
There should be a Ask to Share Slides button, or a Share Slides button, which does it if they're loaded into Meet Echo.
So I've got the meeting materials in the folder. I hit the folder button. I see all the slides there. Or is there a different? Okay, I think I'll.
Meet Echo or in the data tracker?
I've got it in Meet Echo.
Right.
Meet Echo is showing the agenda and the slides.
Right. So once they're in Meet Echo, you should be able to press Ask to Share Slides, which is next to the Raise Hand button and the Unmute Microphone button, and that should give you the slides to share.
I'm not seeing that. Oh, share preloaded slides. Okay, that's the one. I keep missing it each session. Okay. Share preloaded slides. Okay, great. But it says no slides available. Marie-José or Jeffrey?
It says no slides available. You should be able to press the settings icon in the top right and then manage slides, and then that should let you convert them. And then once they're converted, you can share them.
So if maybe I can try share my screen.
Yeah, could you do that? And then we can get started.
You should see my window, right? See my screen?
Yes, we can. That's great. Okay, welcome everybody. We are gathered here today. So good morning, good afternoon, good evening. I'm Eve Schuler. That was Jeffrey. Marie-José is online as well. And we're having an interim in preparation for the IETF 113, and we are specifically here today to have a discussion around what topics we feel are essential to the working group and are in topic versus in scope, out of scope, and hope to have a healthy discussion. In fact, to have hopefully a continuation of the discussion, the very rich discussion that's been going on the mailing list. So thank you to the many people who've been participating at a pretty detailed level. And so we're hoping to drill into quite a few topics that have been filling the airwaves and the mailing list and leading to terrific debate. Next slide. we'd like to remind you of the note well that the IETF has a series of policies, processes and policies, and in particular, making sure that we are forthcoming in the coverage of what topics have patent-related material that's that we're discussing. And you also should know that these activities here today are being recorded, and therefore, if you are here, in some regards, you have acknowledged that you're willing to be recorded and such. And of course, we respect privacy policies. And I think most importantly, something that we've really valued on the mailing list and what we expect today is just treating each other with respect and creating an environment where people feel safe to share their ideas. And if you would like to drill into some of these policies further, there are many other documents to which you can refer. Next slide. A reminder that the IRTF is really different than the IETF, although they are synergistic. The goals of the IRTF are really to conduct research, and that it's not a place where we are standardizing efforts. We are really conducting the research. We are offering a haven for the discussion around the research. It may or may not lead to standardization efforts, but it's quite a separate kind of activity. Next. Today, we are going to begin our agenda by really welcoming Adrian to come and present the semantic routing work, for which he and his co-authors have written quite a body of work. And so we look forward to that. The COIN research group, so Dirk is going to help us by proposing some thoughts forward. He's done a good job to summarize some of the topics, recurring topics, and referring back to the charter and to the mailing list on key points that have been part of this discussion around scoping, what's in scope and what's out of scope in the working group. And we are delighted to have Stefano Silsano here to talk about extensible in-band processing, as well as Nick Sultana to present work on flight plan, which was part of NSDI this past year. And then we will conclude with a couple of students that Marie-José has invited in to talk about their work. We will conclude. We are going to try to keep to a tight schedule. We have a little bit of leeway in terms of discussion, but we will try to keep you on track. Well, you made it here, so you figured out the MeetEcho link. So welcome. The blue sheets will be automatically created, and there's an icon up at the top for helping to contribute to the minutes. There's also a chat feature and the mailing list if you aren't already on it. Here's the pointer to it, and the meeting materials. Now that they've been loaded successfully into the tool, can also be found in the data tracker. Okay. All right, without further ado, Adrian, over to you. Any other comments, however, Marie-José or Jeffrey?
No, not now.
Okay.
So you want me to try to use the MeetEcho tool, or should I just share screen?
I think Jeffrey's bringing it up.
Okay, that'll work nicely. So thanks, and thanks for having me in the agenda. Keep this under 20 minutes to allow a little time for immediate questions, and then maybe the rest of the questions can come in the discussion piece at the end. So next slide. So yeah, introducing semantic routing to you all, finding out which bits sit comfortably inside COIN, not having a rehash of what's in the IDs and the papers and the email threads, and not debating the value or lack of value of semantic routing as a thing, but trying to open up what research we can do within COIN. So next slide. We came across a number of questions. Part of this comes from discussions with Marie-José, and some of it was the questions I was already floating. And we want to run through these to try to understand what's of interest to COIN and what fits in COIN, and along the way tell you what work we've already been doing and what we want to do in the future. Okay, next slide. So what is semantic routing? What's all this fuss about? So you can go and read the background. There's a draft introducing it. There was a bit of a thread on the COIN list. To re-emphasize, we're talking about IP level packet routing and forwarding. That's the next hop style of routing at layer 3. To address the question of how is this different from routing today, routing today makes routing and forwarding decisions based principally on addressing and a few other fields. What semantic routing is trying to do is open this up to different forwarding treatments for microflows to allow varying types of service for the applications and make better use of network resources. And it's doing that based on information not normally used for these purposes, information that may be already carried in the packets, or may be carried in existing fields through overloading, or may be added through new fields. And all of that is about making advanced forwarding decisions beyond simple lookup. So I'll come on to how that fits with network programming and how that fits with computing the network. And then finally, a discussion of a more formal definition. So next slide. Again, there was a draft on this and a discussion thread on the COIN list that you can go and read. And some of that comes to what is the difference between programmability and programming. And as Marie-José has just commented in the chat, there's a difference between network programming and data plane programmability. So we need to pick away at that a bit. For semantic routing, this is chiefly about programming forwarding tables. So using the SDN architecture to push forwarding tables into the devices. And that assumes that routing is run centrally, although it could be distributed and hybrid. And that could start to nibble into computing the network with network programming. So just to stress that the SDN network programming approach is one way of doing semantic routing. It's not the only way. Using it does change the forwarding action. So it does not change the forwarding action. It's still a table lookup, but it does provide additional functions and also reduce some of the functions. So there's some trade-offs. It can be used to mitigate some of the risks and concerns with semantic routing, but then it introduces other problems and single point of failure type of issues. So there's lots of pros and cons, and it all needs coordinating with how the packets are marked. So programming the edges of the network. The question will be, and we probably come to this at the end, is COIN interested in these aspects of SDN and programming? They don't seem radical or new. That's the kind of thing that OpenFlow was invented for. But the routing algorithms and related issues are new, so maybe they're in scope for COIN. Next slide. So, yeah, computing the network, which is, a big piece of what COIN is about, obviously. There's no draft on this or no discussion document on this at the moment, but there is some material in the COIN list for background reading. And this is quite an open thing. So this could be about building forwarding tables using algorithms that are installed onto the network nodes. It could be about using an algorithm on the network node to actively determine the forwarding actions per packet. In other words, running that algorithm as the packet arrives. And then those algorithms on the network nodes, they could be built into the devices. And that's essentially what happens today for routing algorithms. If you're running an IGP, there is a routing algorithm and it's built firmly into your device. Or they could be installed into the devices using network programming. So you could be pushing little or even large programs down into the devices to get the devices to act either generally to build the tables or per packet. What this is not, and I suppose this is my opinion, but what this is not is algorithms or programs actually carried in the packets themselves. So this is not active networking. I think John raised that on the list. So semantic routing works with all of these approaches, including the central algorithms on the previous slide. And computers in the network then is a facilitator or tool that could enhance semantic routing. So again, the question we're going to have to come to is how interested in COIN is this? And I'm assuming that static algorithms as used today are not so interesting for COIN, but that algorithms that are installed by programming and sort of mini compute on the devices, that could be of interest. And then we have to consider what programmability in the network does semantic routing require and what would it drive? So next slide, please. I tried to collect here some of the points that were made on the list, just so that we can pull them out and flag them. Question was, is this an engineering problem or a research problem? Those of us who've been writing about this are not looking for a solution. We're looking to evaluate and research around potential solutions and to look at abstractions. And there seems to be a lot of research projects and papers out there. Haven't we always done semantic routing? Well, as I previously said, to some extent, all routing is semantic routing, but there's a wide variety of needs, and there seems to be a lack of a generic approach and proper research. Distinction between routing and forwarding, yeah, it's complicated, but to do forwarding without a sound view of routing will result in loops and drop packets. So there has to be this cross-fertilization between the two. And the easy part is programming the forwarding plane and doing the lookups. Do we need a unifying abstraction and an abstract academic or rigorous definition of semantic routing? Yes, we desperately need that. There's related work out there, but I don't see a nice tight definition. So there's something to be done there. Standardization, absolutely, we're not talking about doing that, but we are trying to understand what needs to be standardized. Do algorithms need to be uniform across the network and so on? And then what is the network that COIN enables and where does semantic routing fit with that? I think that needs broad discussion in the research group, and I don't believe I'm qualified to talk about that. Yeah, thank you. Where is the community? Well, again, we started a survey. We're well behind with that because since we started it, we've been prodded with lots of other pointers to research. We do have a wiki trying to track stuff as well. The topic has popped up at a number of conferences and workshops in the last year, and we pulled in some side meetings at IETF, not specifically about semantic routing, but related. Those are the IDs that were mentioned up top. And we have a mailing list, which we set up sort of in the interim until we were sure that we were supposed to be talking about this in COIN. So there's a bit of crossover there. Next slide. What do we want to do and what do we not want to do? We don't want to spend time building or promoting solutions. They may already exist as engineering or research, and that's great. We want to hear about them as research and experimentation. And then we want to try to influence that research and experimentation through consideration of the abstract concepts and architectures, the pros and cons of semantic routing, and the risks and challenges. And one of our drafts is trying to pull out very explicitly the challenges and risks to routing systems of doing semantic routing. Yep, we want to generalize those challenges as well, if possible, across all routing research, even though our focus has initially been on semantic routing. And then, unsurprisingly, we want to bring together the community of people who are researching in this area to try to get wider thoughts and opinions. And next slide. This is really discuss. There's a list here of pieces that maybe we can bring to COIN, and we need the view of the community and the chairs and of Colin about which of these we're okay to bring to COIN, because we don't want to waste people's time, and which of these we should take somewhere else, and if so, where. And I'm not going to read through all these, but maybe we leave that up as we move into any discussion, if there's time for that, chairs.
Ask his question that he had on a previous slide.
It says Eve is speaking, but I don't hear her.
Of course.
I'm sorry? Are you hearing me?
Yes, we are. Well, I do.
Oh, okay. I was asking whether Jörg would like to present the question that he typed into the chat earlier. Dirk, go ahead.
Just fiddling with my microphone here. Yeah, I mean, we have been discussing this question a bit further, and as Dirk Trossen pointed out, that John has alluded to this on the mail. So the slides don't have numbers, unfortunately, so I can't refer easily to one back. But I was essentially curious that most of the points on the slides were pretty specific about forwarding decisions, whereas I'm still struggling to see what the bigger picture for the routing part that could get instantiated, how is that envisioned, and what kind of possibly interesting questions would be arising that I've failed to grasp from the presentation so far. Maybe Adrian, you could allude a bit more or explain a bit more about thoughts along these lines.
Yeah, sorry, it's really hard to get through all of this in a short period, but a really simple way of looking at this would be if you took an existing routing system and you installed static routes on all of your routers, you would probably not be surprised if you accidentally built routing loops or forwarding loops, because you don't have any overall coordination of how to build the paths through the network. So where routing comes into this is that if you are making forwarding decisions based on information in packets and something that is programmed into the nodes, then you need an overall coordinated view of routing. You then put that together with the fact that you are trying to make these decisions on microflows or even per packet basis based on information carried in the packets, and you are setting yourself up for some very confused forwarding loops or drop packets unless you have the coordinated view of the routing algorithms.
Effectively, you would have a routing algorithm that would have a certain more attributes to enter into the tables to make forwarding decisions, and possibly dynamic ones. But otherwise, this is a fairly generic description of how routing works. Not that I would know much about routing, besides the basics, but
yeah. So I think you're right that it's a fairly generic description of how routing works, except for the fact that routing hasn't been doing much of this, and care has not been taken as people propose specific individual extensions to the routing about how those behaviors would overlap and how they would impact the stability of the whole routing system.
Individual in the terms of regional individuality or regional differentiation, or as you mentioned earlier, microflow differentiation, or
yeah, I mean, something we look at a bit is if you deploy this in your own domain, well, you can go ahead and do whatever you want, and that's fine until it leaks or until you need to start merging your domain with another domain or bridging or whatever. And I think if the internet teaches us anything, it's that over time, what was a few interconnected domains has expanded into quite a large mesh of porridge, and it is not necessarily safe to assume that what you do in one domain will not impact what happens in another domain.
I'd like to move the queue along and try to wrap up in the next few minutes. So Dirk and Nick, if you could ask your questions quickly.
Yeah,
That would be great. And then we can queue up for further discussion at the tail end. I think it'll be helpful also to hear Dirk Trossen's summary and points as well.
okay, thank you. Can you actually hear me? Because what
We can.
Okay. Okay, thanks, Adrian. Would it be correct to say that so what you call semantic routing here is an attempt to do something like what, for example, service function chaining is doing, or NFV, management and control, management orchestration is doing, but this time on the IP layer? Is that what you have in mind?
Yeah, I mean, it's funny you say it like that way round, because I come from the other direction.
Yeah.
And when I was working on service function training, I was thinking, oh, we're building another routing layer, but we're building it at an overlay. So yes, this is about tagging packets, and it is about getting them to a next hop in the layer. And I'm stressing that because in service function training, you're talking about getting to the next service function node. So you're going one hop in the service function training layer, which may be multiple hops in the underlay. So here we're talking about getting hop by hop in that underlay, trying to select links, nodes, paths that best fit the the nature of the packets being forwarded.
Right. But so in a world where basically everything is encrypted by QUIC these days, what is the information you want to base your forwarding strategies decisions on?
Well, if you mean when the packet comes into my network, it will be encrypted so I cannot look deeper, then you might be right. And then solutions here are entertaining unless there is something you can put in the packet header all the way along. After all, the destination IP address is not encrypted by QUIC. So looking at the implications for security is a really, really big part of all this. And my feeling is that people who have been proposing various semantic routing approaches have not been adequately looking at the security implications and practicalities.
Right. Yeah, so I think I would agree to what has been discussed on the chat, that this really needs, say, an architectural overview and discussion, and also how it, relates to well, internet security, transport layers, and these things. So of course you could imagine, to do many things and do some SDN control and sorts. But I'm really wondering, I mean, what is the applicability domain? So is it something you would do in your enterprise network? Is it something you would do on the, say, interdomain internet? Or it's really difficult to understand, difficult to imagine even.
Okay, and I'm trying to stay away from discussion of individual solutions, but there are various ideas kicking around at the edge of the IETF about flagging packets with the behavioral qualities that an ISP should provide to meet the needs of an application. And that's just an example, but it takes you out of the deterministic networking limited domains and puts it into a much bigger ISP context.
Mm.
We're going to have to move on a bit. Nick, why don't we hold your question for the discussion, because I think this is going to continue into Dirk's talk as well. Thanks.
Move to Dirk. I would like to a bit summarize what has been said on the list and everywhere, and a little bit okay, so it's called Some Thoughts on Way Forward, and I'm going to jump the gun a little bit, Dirk. I think, Adrian, one way to look at semantic routing in the context of COIN is maybe put a step backward and asking what I asked you on the list is, once we have packet programmability in the data plane, not in the control plane, not in management plane, on the data plane, what are the implications for routing? And basically, how is semantic routing a good use case for that? And not because I think there was an awful lot of traffic on routing last week on the list. And I'm sure I've read Dirk's slides, so I actually know a little bit what he's going to talk about. And I think there's also an incredible amount of cool work that can be done within the COIN umbrella. And so routing is one aspect. There's others. And if you want to take the lead in looking at how packet data plane programmability impacts routing, and you can get people to join your movement, I think it's fantastic. But I would have a tendency to, as a generalist, to say, okay, so we have packet level programmability, data plane programmability. How does it impact routing? And then, yes, there's this cool application maybe called semantic routing that makes sense. So again, I don't want to take over Dirk's presentation. So that was my concluding comments about this part of the presentation.
Okay, I'll take that as a hint for me to start. Thanks very much, Jose. This is kind of like, I mean, it's certainly related to what we heard before, but it actually comes out of a parallel exercise in a way, discussions I had with co-authors of some of the work that we're doing. I, in particular, am trying to understand where some of the work that we're also currently doing fits in, and trying to understand how this goes. And this triggered the email that I sent to the list, and I wanted just to summarize those things just as a discussion of where we could go as a research group. So this, I said, you can read some of this in relation to semantic routing, but it's not intended to. It's really trying to help us, or at least present from my side, how I see where COIN is, what COIN does, for people to disagree, push back, or agree with, hopefully. Hopefully not all I'm saying is going to be nonsense. So next slide, please. So as I said, this is an individual understanding of the scope and intention of COIN, the way I've understood it. I've been involved in COIN, I don't know, probably should go back to 3 years or so, certainly before I started at Huawei. And trying to look at COIN as a community effort through taking input from Charter, as a visible agreement of, at some point, what the COIN community agreed upon, what this should be about, but also by talking to people and co-authors and community members, and thinking of what we discussed on the list. But again, want to stress it's an individual understanding. You may very well disagree, and I expect you to maybe also agree. Ask questions to the community on this understanding. Do I get it right? Are the questions maybe the right ones, possibly the wrong ones? Maybe there are no good answers. Maybe there aren't even good questions to start with. I don't know. The goal is that we discuss how to possibly get a better understanding how we could go forward. And I paraphrase Dave's email. I left out, I know he talked about routing there, but I think we can paraphrase that with anything in mind. We have ample basis for a lot of pieces that we discuss in COIN to work on from a research perspective. And the question is really what brings the COIN energy to the party. That's kind of inspired a little bit to look at this from my side. It's not targeted, to make this clear, it's not targeted towards specific outcomes like rechartering. I took the charter as an input because that's what people encounter when they type COIN IETF into the search engine. It's not the intention to suggest this, interpret what we've agreed and written down so far. Please, next slide, please. So observations. So I tried to tease out core aspects, core concepts, how I understood this, words that have been flying around, descriptions for concepts that have been flying around. Compute in the network, we hear that a lot, and in the recent discussion also John chimed in, that was the terminology has been used. You can also find it in the charter, you can find it in a number of documents. So it seems to be something that people care about, which I guess comes from the name probably. It's not active networking. Adrian pointed this out before in a different context that John responded there, and seems to be, it seemed to agree to this. Programmability of the data plane, as Jose rightly pointed out, that results from the compute in the network vision. So can we do something on the data plane that's just more than a relatively static table lookup? And again, we see this in a number of pieces that we presented, not only through the work on SDN P4, also a number of the use cases we captured in the use case draft, really make use of that. You can see it comes out of those examples. Cloud Edge Continuum, that's being used as a word, I think, in the charter, but also in other pieces, specifically to move beyond just packet interception and do move towards computation. So that's kind of the way this is presented there. Orchestration, I think we've seen there are aspects of this in the use case draft. It does talk about orchestration, need to orchestrate the research usage within the compute network. So how does this all come about? It's all nice to have programmability in a switch but how is it placed at the right switch? How is the conjunction of computations in several places in the network properly being well orchestrated? That seems to be of great interest. Decentralization, I find this personally quite interesting. I've played with this quite a bit. There we have would count probably 2 use cases that are quite heavily that are quite heavily centered around decentralization. So the move beyond just the data center, not because necessarily we talk about compute in the network, but also the fact that the participating end nodes that are not technically in the network are also becoming much stronger part of the story than there's a compute with a network and the only outside element is the data center. So there's a very strong element of that. I may have missed something. These are the bits, again, the bits and pieces that I teased out. Also didn't want to overcrowd. Possibly missed something likely. And probably quite interesting to hear from folks about a very, very strong and important aspect that may be missing that add to that discussion. Next slide, please. Then other observation I wanted to do is on the intended methods. I know this is the IETF. We had a lot of discussion around this, the IETF, and this is not the IETF. But there are hints, obviously, in our own work, but also in the charter as to already what the intended methods are. The charter talks about use case-driven requirements analysis, and we've progressed that. It's probably, I don't know if it's but probably one of the most collaborative pieces of work in COIN that's being through the draft. I think we are now at 6 or 7 co-authors. Identify benefits, that COIN may bring, but also even describing what an experience of compute in the network may look like. I think that's very useful for people if they want to understand things. So that's a method, and it's quite common to do that. I mean, it's not only COIN as an RG is doing this; other RGs have done the same thing, of course. May come from outside or from within the COIN community. We've also gained, and you can see this through the co-authors, we've gained co-authors that we brought in from outside the community because they happen to have worked, and this is kind of like how an RG works. So not only the folks that are regular coming to the meeting, but dragging also people to this. Research on new users, languages, abstraction, architects explicitly mentioned. I think that's where we see a lot of the presentations that are being done. So in order to attract the wider community to bring their work to COIN once they either realize COIN might be a right place, or somebody in the COIN community may think these people should present here, right? I mean, we've seen both ways, people coming to COIN, people being pulled into COIN, and I think that's a good thing, right? Also mentioned, there was a bit of a discussion, this is the IETF, and we shouldn't do certain things. The charter gives us an idea that we should pay close attention to work in other RGs. That's quite natural, it seems. So see what's happening elsewhere, not just in the community, but also in other groups. Specifically, I definitely ICNRG, I forgot who else was mentioned. Definitely ICNRG was mentioned in the charter. And we can see an overlap also of constituents here, people who are active in both of these communities for good reason. But also the interaction with the IETF is being mentioned. So avoid proposals in particular, there's an aspect mentioned that would increase the friction between privacy and working computing. And also before the discussion with Adrian, we mentioned aspects on security that would need deep consideration. So these are the intended methods are probably not surprising, but I wanted to put them up here. Was a bit of discussion, but I also wanted to clarify that the vehicle for capturing the discussions are very varied. There are internet drafts people have been putting together. Myself, I joined 2 different internet drafts, and I say joined, I didn't create them. But we also bring in papers, people send their GitHubs around. Doesn't really quite matter. Internet drafts are probably a form of a vehicle that a lot of people understand, but we also have a lot of papers floating about, obviously. Thanks. If you could go to the next one, please. So that then led me to kind of look at, this would have been an animation if it hadn't been a PDF. Now you see it all, which is fine. The light blue pieces you can probably see and recognize quite easily, both in pieces of work, but also in discussions on the main list, and even better in the charter. I posted these scope numbers in the charter as I perceive them on the left-hand side. This is what the scope 1, 2, 3, 4 means. So if you look at the bullet items in the charter, they're reflected there. So it starts from the bottom on vision and technologies from compute in the network. That's a very, very clear thrust of work. Personally, I would like to see more there, but we have a lot of technology presentations. On the other hand, there's a lot happening there as well. Distributed computing frameworks and languages that build on top of this, the vision as well as the abstractions that are being created through this visions, through the vision. And no, we have a thread which has gone a little bit dormant, I think, on the distributed computing framework, Dirk's and Jörg's work. But I also know there has been related work that's happening. I recall a paper that Dirk submitted in the ACM-ICN conference that I see directly related to the distributed computing frameworks that could be used there. So there's a lot happening there. It's obviously bang in the scope. It seems to be. And then I introduced, and I know it's a terminology you can push back on, but they are listed in, and I just stuck a name on it. I called it applicability area. It may not be a very good name, or heck. The areas are the blue ones, light blue ones are already listed in the charter, and we have ongoing in transport. We have ongoing activity. Ike, Klaus, and myself, we are co-authoring a draft on transport issues that are looking at issues that arise at the transport level through programmability in the network. That was the call that Ike recently had on the list for co-contributors, people to join us in this effort. And I think the next presentation that's being announced is one of the ones that we actually try to pull into the COIN group to help us in this area. Privacy is another area that's been mentioned. There's been some work going on. Data discovery was an item. I know I put it now in dark blue. It was an item, but I also think it has gone dormant quite a bit. Mike McBride was working quite a bit there. Some time ago, there were also internet drafts on this where he summarized the discussions. Routing, you can see that as within the terminology I'm using as a applicability area. Again, the same question, how is future routing, and whether it's semantic routing or routing, I left the semantic out here. How is that impacted by the capabilities that the items below give you? The capability of compute in the network, but also computing framework and languages that would allow you to write routing as an app in a way, right? And maybe there are other applicability areas, right, outside that I may have missed. So that was kind of the one that I used on the mailing list. And if you go to the very last slide, that led me then to a number of questions I just wanted to throw out. That's the question, where do we, and I said, where do we want to see progress? I have my own view where I would like to see more progress, but I want to push this or put this to the community. Vision, well, the positioning and the delineation, I think, is very, very important, in particular towards edge computing. We had quite a bit of discussion, particularly in the use cases. The courses may remember a bit of that on, where's really the borderline between edge computing and computing in the network. Well, if we assume that maybe putting an application level server through NFV somewhere in the network, is that really the same thing? Is that computer networking, or is that edge computing, right? So I think that's what work on vision could really help us, because this is also a question that I receive very often. I invited a few people to join COIN, and this is very often one of the first questions you're getting is COIN about edge computing, right? Technologies, what is possible enablement of this vision and the architecture of COIN? We have quite a lot on that. I think that's good, because that's, I think, is the easiest area to invite outside research into the COIN group. So I think that's probably quite easy to say. That's probably something that also others may feel quite strongly in keeping as a progress, right? And applicability is something that not only because it's in the charter, but it's something that's always very, very useful, because it allows us to describe the impact on existing or discovering new areas. Transport was included because we wanted to know how transport would be impacted by the ability to start fiddling around with stuff in the middle of the network, right? And it seems to be quite obvious, and privacy was another one. And now we're talking about routing. How could routing be impacted by the fact that you could do more intelligent decisions in the network? So applicability is something that's very intriguing, because it can be very, very powerful, if you will. The question I asked on the list, and I think this goes towards linking back to Dave's email, he specifically asked for routing, is once we do, the problem with applicability areas, of course, the ... in between that you can see on the slide there. Do we want to focus on any? So the world is our oyster. Do we want to focus on a few? Then the question is which ones? But maybe apart from selecting, which is sometimes very, very difficult, I'm not suggesting we do or we follow somebody's selection, particularly not mine. But if we do something and we look at applicability areas, what are the key questions that we ask when we do so? So we pick an applicability area, to ask almost immediately as to what are the key questions from a COIN perspective that looking at this applicability area may pose that would be really, really interesting, right? But then also how to connect. This is something that we discussed, and this was something that came to discussion with Ike. How do we connect to other efforts? This could be other RGs, it could be the IETF as well. But this came in transport as to, is this something where we may want to feed this whole idea of computer networking into the transport area, into the IETF, in order to early expose this thinking to the engineering, to the IETF community as well, right? And you can ask this similarly in some of the other areas. Okay, that was essentially mainly asking questions and giving an understanding from my side. You may, and I hope you either agree or disagree on this. Thank you.
Any questions? Probably have time for one, and I don't know, Nick, if your question from before sort of bleeds over into this. Otherwise, we can hold it. But thank you for a great presentation, Dirk. Really appreciate the summary and suggestions. Stefano.
Thanks for having me. Thank you.
Hi, can I share the screen?
Yes.
Okay, do you see my screen?
Yes, we do.
Yes.
Okay, so good afternoon, everybody. I'll present in this talk the extensible inbound processing. So a quick background on network programmability. Of course, I do not have to convince this group that network programmability is important. So we think that thanks to network programmability, we can enhance the network layer. And so we think that we can move from the situation in which we have an end-to-end internet with a simple network layer. And we want to achieve a situation in which we have a feature-rich network layer in which hosts, routers, virtual function in data centers can cooperate at the network layer. So the very quick recap, with the extensible inbound processing, we want to define a generic and extensible mechanism to carry information in IPv6 packet headers, like, for example, monitoring information to be collected in transit, parameters to be used for packet processing. And what we want to stress is that nodes can read and write this extensible information, and nodes can take packet processing decision depending on this information inserted in the packet by the source and by previous intermediate nodes. Of course, the IPv6 header is already extensible by definition. So there are several mechanisms that have been designed for the extensibility of IPv6. There are extension headers, there are options inside extension headers, but we know that there are practical barriers to this extension. So we say that the layer 3 functionality is rather ossified. So we are trying to collect requirements. We want to collect requirements from a few use cases and then define this EIP mechanism as an extension approach, and of course trying to overcome these ossification barriers. And we will base our work on open source prototypes. So we want to make design ideas and then to turn them into prototypes to support this process. So the idea is that we can have a kind of generic extensible mechanism that will be carried in the packet headers, in the IPv6 packet headers, and we can support different use cases. So here I have just listed some use cases. I will discuss some of these use cases. I've added the semantic routing. I'm just referring to what Adrian said, that you may want to transport some information on the packet, and only these aspects can fit here in the transport of additional information in the header. And this list is just an example right now. So I'm looking for feedback to understand which can be a useful use case to carry additional information and process packet based on this additional information in the packets. So I stress that I don't think that this paradigm can be applied in the whole internet from tomorrow. So I think that we can focus a solution that work in limited domains. So there are other examples in IETF of protocol of mechanisms that have been defined for limited or controlled domains. This is also called it. So I think that this new mechanism, this EIP, will work in limited domains or controlled domains. So I start with the one use case, for example, contractual networking, because I've been discussed this in previous side meetings in IETF. So this is from this discussion in IETF side meetings that started this idea on EIP. So what is a contract? This is my view. It's a complex and distributed service offered by a network. And this complex and distributed service is composed by several service components and features like forwarding, metering, filtering, accounting. So a service will include all these aspects. And in order to support these features, we may need to add and modify information in the packet on the fly. Talking about contractual networking, I think that we have two phases. A phase in which we can negotiate a contract, and this is the control plane, and a phase in which a contract, this service is enforced. The packets are processing according to the negotiated contract. And I just want to stress that with EIP, we want to focus on data plane. So the enforcement, the monitoring phase, the data plane. So we are not focused on control plane, on the contract definition, on the signaling about this. So we just focus on data plane mechanism, what we write, what we read in data packets to support our services. So I just repeat somehow the processing and forwarding on packet based on EIP is based on the combination of different information. We have some information that can be inserted by the source node or also the edge node, if we consider that packets can be encapsulated by edge nodes into new packets. So in this case, the edge node can play the role of the source and can start writing this EIP information in the packet. And then the following nodes in the path can dynamically insert information in the packets. And of course, so we can base the processing of the packets on regular layer, the current existing layer 3 information, the routing information. So the combination of all information determines what we write on the packet, but also where we send the packet. So we can achieve with this information that is inserted in the packet a network-wide dynamic and stateful packet processing. So if we want to go into a little bit more details, if we want to define AIP, I think we can, to answer two questions, what we put inside this new IP header, let's say, and this will be based on the services that we want to define, the use case that we will support using this EIP information, and where to write this information inside the IPv6 packet headers. So considering what we write inside the EIP header, of course, the content of this information will be defined based on the requirements of the different use cases. So we need use case, of course, to achieve a complete definition of EIP. But what I can already envisage is that some requirements will be common to different use cases. And so that will be the added value of having this EIP with respect of the other existing extension mechanism in IPv6, that we can put together different use cases and make some common information that we add in the packets. For example, timestamping can be a feature which is common to different use case. Authentication, so with HMAC, it's another feature that can be common to different use cases. The identification of a contract, if we think of to contractual networking, which in turn can be many different types of contracts, but maybe they all share the notion of an identification of a contract. So we can also, talking in terms of implementation and specification, we can achieve a kind of library of protocol components that can be used then to implement the different use cases, and also future and further use case that will be defined later on. So the second question is where we carry the information. And okay, here we have the IPv6 header and its extension headers. We have several possibilities. So we have hop by hop options. So we can define the EIP as a hop by hop option or a destination option. And then inside this, of course, I repeat, we will have TLVs, sub-TLVs specific for the different use cases, and some that are common to more than one use case. Also, we have the segment routing header. So this is another opportunity, because segment routing header is also extensible. It has the notion of TLVs. So we can carry an EIP TLV, and this in turn can have sub-TLVs. And we can carry it also inside the segment routing header. So I think that currently these are different alternatives. Of course, in the end, maybe we will select one. For the time being, we have started some initial brainstorming. So I have an initial document in which I propose some format for these options or for these TLVs, and make some example of some TLVs like the HMAC or like the timestamping, that I think that can be general for different use cases. So I will continue with a couple of other use cases in addition to contractual networking, just to give the idea and to try to gather feedback and other ideas. So deterministic networking has been standardized in these RFCs, and the RFC of deterministic networking explained that there are no limitations in the current IP data plane to support deterministic networking. So they say that, okay, we have done an IP-based implementation with this limitation. But if we can add explicit information in IP packets, this can simplify the implementation of deterministic networking in IP routers and hosts and provide additional features. So, for example, EIP is very well suited to this purpose. We can use EIP to support the needs of deterministic networking. Another example is slicing. There's a lot of discussion ongoing in the TS working group of IETF, and there is a framework that is described in a draft, and we need at least an identifier in the packet. There are many proposals. What we say that in IP, of course, we can support a slice identifier, but we can also support requirements and features that are a little bit more complex. They are identified in the document, and so we can complement and extend the currently proposed solution because, of course, if we can carry more complex information in the packet, you can do more. Okay, I have another couple of technical comments for the further discussion. Wire speed processing. Of course, we target wire speed processing. We know that it's a problem, but of course we think that we will require hardware support to achieve high speed processing of this information, and this will need to be taken into account. So if we want to design a solution that will be implemented by hardware, we need to do something which is hardware friendly. And of course, we think that it's possible. Of course, depending on the use case, we may have some constraint, but we think that we can achieve wire speed processing for the use case that we will consider. Security and privacy. Yeah, security, of course, is a concern because having nodes that write information that then is used by other nodes to modify the processing of a packet is obviously a concern. First answer, we are working on limited domains, and this is the first answer. The second answer, there are mechanisms like HMAC as done for segment routing header in SRv6 that provides authentication of nodes that have changed information in a limited domain. So in a limited domain there are already established mechanisms to have a trust of the information which is changed by, for example, a router and needs to be read by another router. Okay, so just in general, I think that our security concerns are rather aligned with those of SRv6 network programming model, and where they have been addressed adequately, and there are already standards for SRv6. So I think that we can work this security concern. Deployability, I've already mentioned that we work in limited domain, and of course we will, when we will go into the definition of specific services, we will also clarify the requirements for the nodes that are running in these limited domains. So in some cases, we will be able to provide a service only if all routers are upgraded with a new feature. But in many other cases, we can support services only when a subset of the router is, let's say, it's upgraded, and there are other legacy routers that nicely interact, nicely support the new feature without this service disruption. Yeah, the prototype. We are basing. The activity is really just started, but we are already building an open source prototype for processing of EIP packets in Linux. This is based on Ebpf XDP, so it is efficient, and the prototype relies on a framework that I've been working on with my research group, a framework for Ebpf programming. So this is why I think we can achieve a very quick prototype. We target to have a prototype in 1 month from now, because we rely on an existing programming framework for Ebpf. In the future, we could also work on a P4 prototype. Question is, anyone interested in such a work? And here are just 2 words about this framework for Ebpf programming that we are using. It's a framework which is described in this submitted paper. Here you find the link to the paper, and here you find the technical documentation of the system. That of course, it's an open source solution. The idea is that we can write scripts in a language similar to Python to implement packet processing operation inside a node. So in order to program the processing of packets in a node, we have Ebpf components, and we are able to compose this with a high-level language like Python. Then everything is compiled, and then it's executed at Ebpf level at a in a very efficient way. So we have this prototype, and we can have a basic prototype in a single node, in which we have, let's say, a kind of development environment for EIP. And in this development environment, we have a system under test, in which we put our functions. So the function that reads and writes the EIP packets, the EIP headers, and we can test them with the traffic generator. So this is the first developing prototype, and then we have another a little bit more advanced test bed, but it's still running in a single virtual machine. And in this single virtual machine, we deploy an emulated network with an IPv6 backbone with dynamic routing. All nodes, of course, are Linux-based. They support they use the Linux kernel to support IPv6. And inside this node, of course, we can put our EIP prototype for Ebpf, so we can test it in a wider scenario that emulates a limited domain. Finally, we also have a distributed IPv6 testbed. So even if the target is not sending packets in inter-domain scenarios, we can also, in any case, test what happens if we try to send IPv6 plus EIP packets in inter-domain real internet scenarios, to see if the packets are maybe just carried without harm. Okay, go to the end of the presentation. Wrap up. EIP is a proposal for the evolution of network layer capabilities. EIP can support the needs of research initiative on IP and internet evolution, because we will have this prototype. We have set up an informal interest group, so I'm asking if people are interested in joining this interest group, provide feedback. We are especially looking for use cases in order to start to continue the definition of this EIP and to go towards to improve the prototype. Of course, we like to write scientific papers. In the long term, we may decide to have IETF standardization activity, but of course, this depends on the feedback that we will receive, and if this solution will be interesting for operators and vendors. This is the home page of the special interest group. Here you find the home page. There is a wiki and a mailing list. and so you can subscribe to the list if you are interested. This is the link to join the mailing list. I finished. Just of course, I'm here to gather feedback. Are you interested in some of the presented use cases, contractual networking, deterministic networking, slicing, or do you have other use cases? Can you suggest this use case? And of course, you're welcome to help us in defining the use case. And in general, whatever feedback you may have on the technical approach, I'll be very willing to discuss here or later on. Thank you.
Thank you so much for a very interesting talk. And it's very interesting that you have a test bed that's up and running. So thank you for that. Thank you for sharing. And I would encourage folks to look into the slides to track down the pointer to join in the conversation and the test bed.
I'm in the queue.
Go for it. Marisha, I was just expecting you to type up.
Yeah, I thank you for the presentation. I'm a little bit confused though about what do you want to achieve within this group. We are not going to give you use cases. You know, we're doing research on data plane programmability, and I would recommend that you look at the existing use cases and maybe tell us how your solution matches and not the other way around. I saw also a ton of references in your presentation to IETF group, which of course we're not one of. I'm not saying the work is not valid. You obviously are looking at an implementation. You talked about vendors and operators. This is not us. So how would you, and it's more like a generic a comment because we're having this big conversation today on you know, what is our research group and what is not. I would actually ask you, what research would you like to encourage with your approach?
Yes, thank you. Yeah, if of course I've been a little bit quicker, but that in the call for feedback that was written, of course, operator, vendors, and academia. So of course here maybe I'm talking a little more also to academia and to researcher. And the point is that I like that researchers also join this effort, absolutely. And I think that use case can also come from researchers. And so, for example, I mean, in the previous presentation, we saw Adrian that mentioned that, okay, we may need to add information in a packet for the need of semantic routing, for example. And this, for me, is a use case that maybe can be turned into some extension to the framework that I'm trying to set up. So this is, I think.
Stefano, you're setting a framework, you're setting an application, you're setting a test bed. It's nice, but it's 11, I should be awake. Maybe I'm not awake, but I kind of not see exactly what you expect from this community.
Yeah. I think that if this community has some interest in doing some scenarios in which nodes are actively reading and writing information in packets, I'm providing a tool and also a framework. And so also people that have these scenarios in mind may, I think, I mean, we could join the work if there are other people that think that a node may need to read and write information in packet on the fly.
Okay.
And I think that this is a part.
And I would tend to agree with you. I would tend to agree with you that the testbed is actually quite an interesting space for for people to research, to do their research. That was my takeaway.
Yeah.
Dirk, did you want to pipe up?
Yeah, I'm kind of given that I'm really quite keen on, maybe we can get something out there, for the use case work that we're doing. No, Colin made me avoid the word draft, but it happens to be a draft. I'm sorry, Colin. I'd be really quite interested in, formulating what you said before. I'm confused by the direction you suggested, and saying, if the community is interested in doing something where you do something on the line, on the wire, I have the tool to do it. That's good. This is good in the sense that Eve just said, maybe we could do some research then there. That's okay. But I would also like to pose the question the other way around to you. I would argue, going in my mind through the use cases we currently have in the use case document, if we actually, could you bring a very, very strong use case into the COIN community in the form of that document, where you said, if you had that ability for injecting these type of extensible information, and you can do something concrete, not just generic, it can be information and you can act on it. That's a bit strange, right? About a use case where it's this is a use case for forwarding nodes on the path, doing something with information, etc. And then it just happened to be that EIP may be a tool to look at that could enable that use case. But this is something I would be looking for, actually, to enrich the use case document with a much clearer use case that cries for a solution that sounds like EIP, right? So that's the part that I'm missing. Not the other way around, that we go through our use cases that we already have, I think 6 or 7 of them, and said, EIP could be a solution. I would really put the demand on you to say, come up with something really cool, very specific as a use case, as they are in the use case documents, and then send us an email. I'm sure Ike, myself, Marita is in there, a couple of quarters that we can add them in the appropriate category, and then we can say, wouldn't be a capability like EIP? Wouldn't that be great to have? I think it's the direction I would encourage to do differently.
Yeah, I accept this suggestion. I think that is exactly what I'm going to do in the next weeks. Defining which is the best use case, and start to work on that. So it's a good point, and I will surely follow up. I think that in hopefully in a couple of months I will have the test bed, but also I will identify the nice use cases, but I'm also asking for suggestion. That's the point, because if someone has a nice idea, then I think that we can do some work together. That's my point.
Oh, but I understand that direction. I understood. I suggested to just also consider the other direction around. Yeah,
absolutely. I will do. If I do not receive any suggestion, of course, I will find my use case.
Yeah. Well, thank you again. And we look forward to the continuing dialogue around the actual intersection between COIN and your work and your testbed and your framework. Okay, we are ready for the next and last full presentation, and then we have a short set of applications that Marie-José and her students will talk about at the end. I think I'm going to turn on the countdown clock. This will be, I'm going to give an extra minute. There, are you folks seeing the countdown clock?
I can't see. Oh, yes, I can see one. Yep. Can I just confirm that you can hear me and see my slide?
Yes, we can hear you and see your slides.
Wonderful. Okay, thank you, everyone, for a very interesting session. It's a pleasure to be here. I recently joined Illinois Tech, but the work I'm describing was mostly done when I was a postdoc at UPenn. So speaking of which, I'd like to start by acknowledging the wonderful people I worked with there, both at UPenn and also at Peraton Labs, who was an industrial collaborator in this project. So the scope of this work is mostly targeted at data center networks, but there are various ideas that can be transferred over to other types of networks. So I mentioned this because the kind of topologies that you're going to see are going to be most easily kind of fit within a data center context, but I'd be happy to kind of discuss further how the ideas can transfer over. So one of the interesting trends over the last couple of decades has been the variety of ways that the network can be influenced both through kind of end hosts and various devices at the end hosts, and also within the network itself through switches. There was a very interesting couple of points made throughout today and also on the mailing list about research versus engineering. And one of the things kind of I struggle with a bit sometimes in academic research is how to get enough leverage technically to do interesting work, right? And come up with new ideas and prototype them. And something that I found helpful over the last over the last few years is that this new language that was originally developed to program switches, and specifically one particular switch design, has been retrofitted and now can target a variety of different types of hardware. So this is one of the ideas that kind of we leverage in the work that I'm about to describe, because P4 became, because of a kind of a de facto kind of standard and uptake, became kind of a common entry point to program a variety of different types of hardware. So for research, we found it to be very helpful. Now, I say program and programming, but how is this actually done, right? So the current paradigm for using this technology involves writing a program in P4. So for those of you who are not familiar with P4, I'll just add some context. It is a fairly limited domain-specific language. It does not support loops, but it's being domain-specific. It supports abstractions that you typically encounter or need when programming the network, such as table lookups, and doing parsing various packet headers. But it's also extensible, and so what happens on different hardware targets is that it's extended to support different primitives. And it's a great way to program network cards and switches. But currently the paradigm kind of follows a one-to-one pattern where you write a program and then you flash it onto one data plane device. Now, this is, it's fairly simple, and it kind of carries over from how we traditionally program, microprocessors, microcontrollers, but it feels that there is a bit of a mismatch with the overarching vision, right? Because this is too kind of coarse-grained, right, and at the granularity of devices. So I'm expanding a bit more on this. This mismatch here. So there is a certain exclusivity when you pick a particular device that you want to program. You also have to reason about the dedication of the target's resources being dedicated to your program. Your program must fit or somehow be shoehorned into that target. And also, we're kind of meant to be programming the network, right? But it takes too much of a piecemeal approach using this paradigm to end up doing the programming of the network. So the motivation for this research is to develop a new paradigm to retain the useful fiction of writing a single data plane program, but have a tool chain that will then help you map bits and pieces of the program into a suitable mix of data planes with different capabilities in order to meet your objectives. And talking about engineering versus research, one of the pragmatic choices that we made here was to continue to preserve the use of existing vendor tool chains, languages, and hardware, simply because we wanted the research to be more realistic, right? So this kind of resonates with points made earlier and on the mailing list, that we don't expect the world to change to suit our idea, but rather, we want to highlight how our idea can complement the world. So we wanted to develop a pathway that will enable a new paradigm, but will also fit within the existing constraints and not require new hardware features necessarily or new language extensions. So what would this look like intuitively? So here I've got a program represented as a flowchart. It's actually a P4 program that I'll give you the link to online. But the idea is to isolate bits of the logic and then have them offloaded to other, maybe different network hardware or hardware that is connected to the network, right? It might be a CPU being offloaded to by a switch or a smart NIC or another switch. And so the idea is then to transform the program in order to do this handover and also hand over back. But we start to see that we gradually appreciate that, hang on, what happens if part of the program fails on part of the switch, right? We need to do some monitoring, right? So we end up with a distributed system. So this makes the problem more challenging, i.e. interesting, and I'll talk about how we deal with that. Another thing I wanted to bring across is that the granularity of the handover should not be prescribed by us, right? So that should be something that can depend on what hardware is going to be available at wherever this is deployed. Okay, so back to the ideas board. So this is the paradigm we're calling data plane disaggregation. So you start with one data plane program and get split into a bunch of programs that can be mapped to different, possibly different types of data planes. And I want to distinguish this from server and switch disaggregation, right? Which mean different things in the space. And I want you to think of it as if we're programming a virtual data plane that then gets realized as a set of complementary physical data planes, right? And conceptually, this is kind of, we see it as the way of using that one big switch, folklore idea, networking, and a pathway to kind of see it as one big programmable switch without having to do a tremendous amount of manual effort to kind of place and split programs manually. And speaking of manual effort, manual effort would be a killer for this, right? So we do need automated support because, as you can appreciate, if you change a program, there's always a risk of introducing bugs. Plus, the program would need to be changed if your topology changes, if your hardware changes, if your requirements change, right? So that is far too much drag on top of the churn that you might have. So part of the contribution in this research is the automation needed. But I'm going to unpack this problem a bit more. It turns out to be an interesting complex of interrelated problems. So as I already mentioned, kind of we need to split the program, and the way the split is guided is based on the resources that different parts of the program use, because those resources ultimately need to be satisfied by the hardware target, right? No use mapping part of a program on a piece of hardware that doesn't have the right amount of memory or the right type of memory or that cannot operate at a certain rate, right? So we need to do kind of a resource-based program analysis. For suitability, we need to be able to reason about heterogeneity. So this is the different types of resources that different platforms make available. And we also need to take account of the user's resource and performance objectives. So this is a particularly interesting part of the talk. I won't get into much during today's presentation, but I'd be very happy to go into in more detail. Since we're talking about different data planes, we need to talk about placement, right? So I think Dirk mentioned this in his presentation earlier. Since we have a mix of data planes, we don't have shared fate. We need to talk about handover. We need to talk about synchronization. We need to detect and mitigate and handle faults. And there's also a bunch of other issues, right? So we don't want to make language or hardware changes. And I have a shopping list of various other issues, including multi-programming, right? If you're running one program in the network, you're going to want to run several. How do you accommodate that? And so Flightplan is a system that tries to accommodate all of this. And we have a research prototype, and it's available online together with a bunch of documentation and scripts to facilitate reproducibility. I was also very interested in Adrian's talk earlier because there is a routing component to Flightplan. I don't know to what extent it overlaps or complements semantic routing, but in order to do what Flightplan does, you have to kind of hijack routing, right? In order to progress a computation through a set of devices that are available in the network. I'll say more about this later. And the high-level idea of how Flightplan works is that you have a data plane program. It is logically split into bits that are physically mapped to specific devices. And then there is a linking process that allows these bits of programs to find each other on the network. You can see I have some duplication here because it also has an inbuilt notion of in-data plane failover, right? So that you can pre-program its reaction in case bits of it become unavailable at runtime. The actual workflow is a bit more sophisticated. And I'm going to focus, in the time I have, I'm going to focus on a couple of aspects that I think are salient. So first of all, I want to point out, this, you can see this as being a junction. All arrows kind of up to this point are pointing into the planner. And so this is one of the kind of intellectual ideas that we're using in this work of reducing different types of information to a common rule-based representation in order to make allocations. Another thing, kind of a pragmatic aspect I wanted to mention earlier is, this kind of boundary here. So here, we're representing the vendor tool chains to talk to different hardware, right? That's typically closed, and we're okay with that, right? So we're working with P4 here, which, as I mentioned, can work with a variety of different hardware, and we want to try to, walk the line between research that's, is a bit more maybe feasible than would otherwise be if we can also assume that we can see inside IP secrets and that sort of thing. So one of the, as I mentioned, one of the ideas that this relies on is abstraction of information. You can see here we're abstracting programs, and over here we're abstracting resources, i.e. hardware features. I'm going to give you an example of how we abstract programs. And this is a P4 snippet, and I've highlighted two types of phrases. The orange phrase is an annotation that we added. And this is not added to P4. This is picked up by a preprocessor that we wrote that will create a topology of the program and will create segments. So here we have a segment called compress. Here we have a segment called FEC encode. Anything between two segments is considered to be, anything between two annotations is considered to be a single segment. And you can put these anywhere. You can put these inside if statements and deeply nested else statements. So the that analysis is automated away for the user. The other phrase is resource-related phrases. So as I mentioned, the analysis has to take heed of what tables and whether we're using specific external functions that might only be supported on some types of hardware targets. And that is used by the reasoning engine to decide where to place them and what type of hardware to place it on. And this is then digested into rules, and the programmer never sees these rules. So the programmer who knows P4 only works within P4, and this dimension is abstracted entirely for the programmer. So this is basically saying if you want to execute the segment called compress, then to make sure that these three resources are available. There is some metadata I'm not showing you here that specify that this is an external function, and this is another external function, and this is a table. So then the reasoning engine will use this metadata to reason about placement. The other thing we're abstracting is hardware features. So we're using a similar mechanism here. So what I'm showing you here is that we're capturing a profile of running a particular function on a CPU compared to running it on an FPGA. And there are certain parameters, such as the rate and the packet size. These vary. And what this is showing you is kind of the side effect of running this function on this platform. If it were to be successful, then the profile, the response would change in some specified way. Now, I think two questions that often come up here are, one, how are you generalizing across all CPUs? And we're not, right? So this is, for simplicity here, I'm just mentioning CPU, but this is actually a specific type of CPU. This is a specific type of FPGA. And the other question that comes up often is, where do these numbers come from, right? And the answer is from profile experiments. So the way we do this is we run a number of we do a little parameter sweep. We check for different traits, different packet sizes, what are the features we observe when we run this function on this target, and we make measurements. And so there's more on this in the paper, and I'd be very happy to talk about this more. And the last thing I'll mention, which is very interesting in this work, is kind of the runtime fault detection and handling. And basically, I wrote 3 types of runtimes that trade off features for overhead. So you can either have no runtime fault detection and handling, and you pay no overhead in terms of network, packet load, and also in terms of memory on the devices, or you can trade it up. And there's a bit level analysis of that in the paper. So I'm going to start concluding. I'm just going to mention evaluation. There are various aspects of this that were evaluated. One of my favorite aspects is running multiple programs that are split in different ways and running on multiple runtimes within the same network, because we wanted to test this idea of, if you have multiple people using the network, then typically they might have their preferences about what they want to run and how they want to split it. So this is an example we did in simulation. Other evaluation results were done on physical hardware. And basically this is showing we have kind of a little topology here with different runtimes and different splits. So what you're seeing here is, with this big arrow, is saying that all the functions are packed into one switch. But actually some of these functions can't be packed into real switches. So more realistically, we would unpack them and then we'd use different runtimes. And all of this variety of programs and splits and runtimes can interoperate. So one of the things that is very low effort is you could try our demo, which takes virtually every single figure. For example, this is the one I just showed you, and makes the experiment interactive, and you can play it. And so this is showing you packets being fired, and this is a reduced experiment, right? So we simplified it a bit to reduce clutter. And what you're seeing here is, these spheres are like extensions to the switch to which it can offload, and the demo will show those pop-ups that come up that explain this. And I want to thank the amazing set of students I worked with to develop this. So if you go to this URL, you can run the demo, and you don't need to install anything. It runs in the browser. So as I mentioned, so that's kind of a very kind of quick tour of Flightplan. As I mentioned, I started at Illinois Tech a couple of months ago. I'm very interested in continuing to work in this general direction, which also brought me to COIN. And I'm just putting this out to in case you want to reach out about collaboration and discuss programmability. I'm very keen on that. One recent things I've been working on is extending what I talked about, that interfaces in network programming with the network, to include application level concerns, right? So ultimately we want to serve applications, right? Otherwise, what's the point in having a network? And I want, I've got a paper and the prototype on how to extract some features or applications and have the network program and the planning using Flightplan to kind of interpose and help facilitate the realization of those features, right? So application express needs, and the network has resources, and the planning process I've extended it to also take into account application needs and also use network programming for that. So with that, I want to thank you all, and I'd be happy to take any questions online or offline if you prefer. That's my web site, and you can get my email address from there.
Nick, for this. I think this is very much, some type of work that I think is very important for our community. The new work seems absolutely interesting, especially with what Dirk mentioned in his own presentation. We can take this offline, but I think that could be maybe something you could present at the next meeting next month. What are your thoughts about this? Because that would be linking Flightplan into work that's already existing in this research group. I just saw that Dirk joined the queue, so go ahead, Dirk.
All right. Yeah, thanks, Nick. A great presentation. I think this is actually fits quite nicely to the discussion here in the group. So what we have been trying to achieve is a kind of understanding how can we bridge this, say, dichotomy between like networking devices, network elements, and say servers. And so, yeah, of course, one approach has always been, okay, let's use data plane programmability, so P4 programmability, and people have developed, say, individual point solutions in this direction. And I think your work is a really nice, say, next step forward towards, say, a slightly more powerful and more networked approach to like this topic. So when one question though, so what do you think? What would be the kind of programs that you would primarily program in this like virtual programmability layer? Would this be something more like, you know, like forwarding enhancements or like more like networking functions, or do you also envision some like more application logic?
Thank you for the question. And by the way, our paths had crossed in Cambridge many years ago, so I just want to say hello. So it's very nice to be in touch again. So the answer to your question is we've looked at all three. So let me give you an example. So this is an evaluation I didn't get to cover in the talk, but this is an opportunity to cover it a bit more. So this is a testbed evaluation where we had two workloads. One was kind of more latency sensitive, key value lookups, memcached. One was more bandwidth hungry. So this is kind of simulating the typical kind of mix of workloads one encounters in data centers. Now, what we're using Flightplan for here is to improve the functioning of the network, but also kind of keep an eye on how applications are responding to this, right? But applications, as we all know, they sit on top of a stack that can quasi-autonomously take actions, right? So Ebpf, for example, this is funneling over a TCP, and TCP is sensitive to the congestion in the network. And so what I'm going to show you here is kind of a progression, an evaluation of an experiment where we're measuring power, throughput, and success and latency of the key value lookup and set. Okay, so this is the base state, and what we can see is that the latency is going to show up as being high because it's being contended by Ebpf. So as this progresses, is we're going to activate functions, right? So this is a distributed program in Flightplan. And I think it will cover the points you raised, right, in relation to forwarding, but also in relation to applications. So what happens is we add header compression, right? So this is transparent to reduce the contention that Ebpf has, and what we notice is that latency drops, right? So more memcached queries get through both sets and gets. Next thing we do is we simulate drop. So this is kind of simulating not congestion, but more of that kind of steady state loss that you have when you have a partial failure of a transceiver or a cable, right? So you have reduced capacity. And what we see is that throughput collapses for Ebpf, and indeed success collapses, right? But then what we do to mitigate that is we add, offloads from the switch to add layer 2 FEC. And what we see is that the power goes up because now we have more devices that are doing stuff. It's not just forwarding, right? It's also doing this in-network computing that is rather intensive. We see that TCP is a bit happier, therefore Ebpf is a bit happier. We see that, however, this is memcached is oblivious to that. So the last thing we added was a key value cache in the network. So this is talking more towards the end of your question, which was about applications. So we have more power. TCP doesn't care because this is working over UDP. But what we see is that successful gets improves. So part of the application's experience has improved. Sets still needs to go through the lossy link. We put this cache before the lossy link. So, it's a bit of a nuanced answer. It's not yes or no, it's a bit of both because it depends on whether you're focusing more on read or write heavy workloads. And latency, again, so the biggest result we see here is that latency can drop because suddenly the cache is much closer, right? So if we have a cache hit, then we get to reply very quickly. Otherwise, if it's a miss, then it still needs to go back to the server, right? So, sorry, this was a slightly more lengthy, but hopefully more information-rich answer to your question, right, about what we can target. No. So it's a bit of everything.
Okay, thanks a lot.
Any other questions? Thank you so much. I really appreciated the discussion here about routing in the service of compute, because, you know, as you could hear from the previous discussion in the mailing list, there's, you know, often this contrast with compute in the service of routing. And I think we need a little bit of both, but it was refreshing to hear this contrasting narrative and framework. And so thank you for coming in and sharing this.
Oh, pleasure. Thanks. And one last thing, if I could just mention, speaking about routing, and so I was very interested in the points that the discussion points earlier around Adrian's talk, right? It's about kind of almost as a per packet routing decision, and you know, appreciating the blurring between routing and forwarding. And I just wanted to say a little bit more about how this is currently set up and configured in Flightplan, where you have, in essence, a runtime that makes the switch a bit more autonomous. So, you know, it's not a full kind of routing protocol, but it gives it some metrics to keep an eye on, and you know, some ability to actuate some changes. And you know, I think there's a lot of space here to try to optimize across timescales, right? So one of the challenges we often face in routing is that the timescale of forwarding is at one level, but the timescale of routing is at a much lower level, right? Typically, you know, forwarding will be happening at nanoseconds, but routing will be happening at, you know, probably minutes.
Right.
So I just wanted to point this out as a space where I totally resonate with the view that there's a lot of interesting research to be done here.
Okay, well, thank you so very much. It seems my students from France are not online, but maybe I will just talk about this experiment that I ran with Telecom Paris Sud from October of last year until about 2 weeks ago, where I took...
Oh, Marie-José, it's looking like your students say that they are here.
Oh, they are here. Oh, great. So, Nicoletta, I will let you present, but I will introduce your talk. Great. So this experiment that I did with about 15 students at Telecom Paris Sud, and Nicoletta will present, which is great. And what we did is a project class on computing in the network. And we essentially started with a lot of, I would say complex ideas, but the project itself, we didn't have hardware. We couldn't do P4. We tried to use the P4 Pi, which is Pi, but we didn't have Pi either. So in order to get the brains going, we started thinking, okay, and Eve, it's going to be computation in the service of applications in that case. It was, let's take an application that is running right now and let's break it down. So let's do the life of a packet. What happens to packets when they cross the application? What number of network boundaries they go to? And let's assume that every time there is a network boundary, there could be some computation available. What would change in the application or in the life of that packet? Would that packet be sent somewhere else? Would that packet meet likely minded other packets? would new services be included or excluded? And Nicoletta and team, they took the smart city, and this is their presentation. Smart lights, once you have networking and processing being together in a smart city. So Nicoletta, you can actually talk for just a few minutes. Can somebody put their slides up?
I was actually thinking to share the slides myself.
Well, they're on. Yeah, okay, that's fine.
Because the ones from the materials are not really, the formatting is not good, some text is not seen, and we want to share our screen.
Okay, and it's fine, the two of you. And you have only a few minutes, so.
Sure.
Yeah.
We can also just talk about it. Yeah. Okay, perfect. Seems like it's working. Can you see?
See, yes, we see. We see your slides. So, yes.
All right, perfect. So I will just try to speed run this as we only have a few minutes. So thank you so much for the invitation. My name is Ranarisa, and my colleague is Dora Tilica, and we did this project with our professor. So basically, it was just a proposal to solve the traffic problems in really big cities. Since this is a time management problem and also an environmental one. So we proposed AI and machine learning as a new approach to manage and possibly solving this issue. And it was a design and implementing a smart AI-powered traffic management system to optimize the traffic. So we would do an initial study. Basically, this would be just to understand how a city works, the interactions between its people and the infrastructure, and in general, the initial study would need to take put cameras to understand what's going on, and we would get all of these variables for in this study. Then the computational program, Dora, you wanna talk about it?
Yes, so thinking of the computational program, we will use the information collected to design, train, and test the machine learning algorithm. And we expect to find different patterns among the variables and identify the relationship between them to produce a program that will optimize the flow of traffic through the waiting time of each signal. We will train our program to identify accidents and other exceptional cases to plan and create alternative paths in order to keep the traffic flow mostly uninterrupted and clear the needed streets for emergency services. Next slide, please. I don't see it. Nope.
And Dora and company, can you move to the slide where you have the architecture, which I think is the most.
Yes, it's the next one.
That's the one. Can you see it?
Yes.
Okay,
yes.
perfect.
Okay, so we will have a local server with the traffic optimizer related to the particular part of the city, to a neighborhood, and the local servers will be connected to the central main servers that will be the optimizer for the whole city. Next. And once we reach satisfactory results from the program, it can be put into real-life operation. And first, we will activate the traffic optimizer on just a specific part of the city to control the best ability at the beginning of the real-life operation, and then expand it and activating it in the whole city. Next. To check that our program is functioning reliably in real life, we will use AI cups, which are actually the smart cameras we used before to gather information data in the initial study. And these cameras will provide real-time information, which is our fog computing part, that will first be sent and stored in the local servers, which is the edge computing part of our project, and then to the main servers of the city, which is our cloud computing part. These are the three main parts of our project. Next.
I think you need to conclude.
Okay, we'll go to conclude.
Sorry.
So yeah, that was in general, that was what we made. Dora explained it perfectly, I think. So we wanted to break down the system and then put it back again to understand how a city works and how to optimize traffic. So we have the fog computing part to understand the little parts of the city, and then the edge computing and then the cloud computing to put it back together.
Okay, thank you. I'm sorry to rush you guys.
No, that's
so the point here is thank you very much for being available and for doing the work. And I think this is actually the wrap up, but I would say, you know, we are a community, and I think maybe the best way of expanding the community is teach them. So thank you very much to you, and actually to the whole class, which was very patient with me. I think we're wrapping up. I think so. This is actually an interesting thing because this went all the way to the applications. And I think the rest of the meeting was about how to enable these applications to essentially work. I think there's a lot of questions that are on the chat. And so I guess there will be more discussions going on. We are meeting in about a month and a week, which will be 2 years after the first meeting was canceled. So it will be hybrid. I think most of us, the chairs, will be online, but we welcome ideas for presentations. We welcome ideas on, again, new contributions, continuing contributions. I hope everybody who presented today will continue collaborating. I think there was a lot of talk about our charter. I think our charter is wide enough to be an umbrella for the research that is being going on. And I think we like the fact that our community has greatly expanded. Philip, the thing is that this is all our architecture right now. We didn't have the time nor the money to do anything else, but there's cool stuff there if you want to talk to them. Anyway, so wrapping up, let's meet you guys again in about a month and a week. Thank you for all the presenters. Thank you to everybody who participated, contributed, being on the chat, being here. Thank you to the discussions that happened before on the list. I think heated discussions are always necessary to bring things forward, so I'm a big fan of that. And again, would Jeff or Eve want to add something else?
Thank you for your time.
So thank you, and see you at IETF 113. Thank you very much.
Thank you.